The Department of Energy has flipped the switch on what is now the world's most powerful supercomputer. The DOE's Oak Ridge National Laboratory facility announced this week that its new Titan system is now live. The supercomputer can handle 20,000 trillion calculations a second, which in computing language is referred to 20 petaflops. ORNL says that this makes the Titan 10 times more powerful than the laboratory's Jaguar supercomputer. Titan gets its speed from a family of processors called graphic processing units, which were first developed for computer gaming, combined with traditional central processing units. Technology Today sat down with Per Nyberg from Cray Incorporated and asked him what the biggest challenge was in developing the Cray XK7 system.
The largest challenge is really about harnessing the computing power of these big systems. And you have to sort of look at how these systems are constructed today. They are what we call highly parallel, which means that in order to run faster, you have to have more and more things going on at the same time. Many scientific applications, however, are characterized by each of those components having to talk to each other. And that's where the difficulty comes in. If you could just farm it out and then just let it run and then you get an answer back at the end, that's much easier than if you farm it out and then they are all talking to each other simultaneously. Because while they're talking to each other, they sort of stop doing productive work. Right? They have to share an answer, for example. And then one can't continue until he's received the answer from another processor.
So turning a science problem into an engineering problem is a very nice thing to have happen. And we do see this sometimes in computational science.
That speaks to computer design and what are called interconnects or internal communication networks, specifically designed for processors to talk to each other within the machine.
What Cray has done is they've incorporated the AMD processors with the Cray proprietary interconnect. That is essentially a way of letting the different nodes or the different elements of the computational system speak to each other very quickly to do these computational problems.
From a Cray perspective, that is where we spend a tremendous amount of research and development in building these interconnect networks that allow efficient communication. You are only as fast as your slowest component. So if all your computational work comes to a halt while you're sharing information, that'll impact performance of the model.
With up to 16 cores and also with the new extended instruction sets that the AMD Opterons provide, they're actually able to compute more science, do more number crunching in a short period of time than the competition and even faster than the AMDs have done in previous generations.
So on the one hand, you need a computer system that can handle this effectively, but there is also what I would say almost a partnership that needs to occur with the computational scientists in writing the algorithms or writing the models to do effective communication at that level. Put the two together, and that's your best chance at being able to run on these very, very large systems.